The highlights I'm going to give you today is about the class I teach in mechanical engineering. It's 201 Elements of Structures. And this is the first course in strength of materials that is taught to students in the 2A curriculum in mechanical engineering. So these are sophomores coming in. And essentially, the class is new. It started in the fall of 2012. And we started off, I had a total clear slate, which is useful, kind of challenging, but you can start from scratch. And the mandate for this class was to teach in a quarter, so only 7 weeks, essentially, strength of material, axial loading, torsion, and bending to incoming students. So I started off the first time I taught it in fall 2012. I taught it in the traditional way, lectures, online PSATs, PDFs, Taylor, the whole shebang. And it was a lot of material to cover in these few weeks, and because it's so compressed, there were no good textbooks, and the challenge was a little too steep. And so we were given the opportunity to develop online content on the MITx platform and offer it on edX. So we jumped at the opportunity, and we started using the tool to develop online content for the course. So I spent the spring and summer of 2013 to develop the course content online and start offering the course on residential in the fall of 2013, experimenting with some of the content online, or a lot of the content online, I should say. So essentially, this course is at this point, all the content of the course is online. The students do not have a textbook. There are lectures, recitation, and online material. And we release a week of content at a time. Every week, we release a learning sequence, problem set. We do a Quizlet. I'll tell you what it is. We release additional example problems, and we release very concise board notes. I mean, lecture notes that are really a couple of pages per lecture. And that's it. That's what the students rely on. So the learning sequences are an important component of the class. Essentially, are sequences of videos and exercises. This class is very task-oriented. The students learn to solve problems in axial loading, torsion, and bending. There is always some structures that they have to look at and figure out how it deforms, what forces are inside, and these kind of things that mechanicians are interested in. So it's really important for the students to have good examples of how to approach the problems. So a lot of the learning sequences are really presentation of what good practitioners do when they approach a problem. And because different students learn in different ways, we present these approaches through videos. We present these approaches to interactive problems. The MITx platform allows us to have the students try the problem themselves and then reveal the solution that the expert does. So we spend a lot of time doing very detailed expert solution to many exercises. And then after they had this kind of practice, they do their own problem set, which is also interactive. They have immediate feedback. And as soon as they get the right answer, immediately they see the detailed expert solution just to match their own thinking and go forward in the problem. And we also embedded a lot of tools to help them not be bogged down by algebra, but really focus on the content on the class. So we have MATLAB embedded, minimal energy barrier to use numerical tools instead of having to do a lot of algebra, pen and paper, and really focus on the content we are trying to teach them. So we do all this. And then to make sure that the students stay on top of the material, every week in class we do a Quizlet. So essentially we do a week of content. The PSAT is due on Thursday. All the solutions are revealed on Thursday. And the next Monday, the students come to recitation, pen and paper, 15 minutes, and they have to solve exactly one of those problems, one of the PSAT or learning sequence, not similar, but exactly one of those. And this changed a lot of the dynamics of the course, because the students are not stupid. They know I have the solution to these problems. One of these problems will be tested on one of these, and is worth 25% of my grade. And so the students learn this content. So it's not like they just do the PSAT, or they copy the PSAT, or they try to understand what the learning sequence is, but not really in depth. They really understand it, and they stay on top of the material very well. And then the other trick that we use is we use a lot of because we cover so much content, we try to stress as much as we can similar structures in equations, in solution strategies, between the different content of the classes. We go from axial loading to torsion. We show similarities between the equations so that the students, as they learn the new material, they reactivate the material they learned in the previous segment, and they draw comparison, and that allows them to proceed faster, in my experience, than what they were used to, without all this support, the structural support. So the other thing that by having all this online content, the other benefit of having all this online content is that I am finally free of the classroom clock. If you have a course in which you're trying to teach something and you do not have the perfect textbook, you always feel like you have to, in the class, impart as much knowledge as possible. And you feel like unless you put it in that amount of time, that's it, you're done, they never get it. And by having the online version of things allows me to take more time in class. So I do a lot of simple demonstration with everyday kind of things to kind of connect the equations that we study with everyday life. And that really helps the student to connect. And the online content also allows us to go in depth in other things that we would not have access to, like simulations of more complex structures. And then finally, we solidify all the knowledge that the student acquired by having them do capstone kind of problems in which we bring together a more complex problem, all the different components that they learn in more simple tasks and more simple problems. And the students are really appreciative of all the material that we make available for them to learn. So I run surveys at the end of the course on what are the components that really helped you learn. And in general, the feedback are very positive. So I cleaned up the questions because it was too much wordy. But essentially, this is evaluation of things that contributed to their learning. And they think the PSAT, especially with the instant feedback, is critical for them. Because unlike the PSAT in which you give the PSAT this week, I grade it this other week, and I give it back 2 weeks later. And you never know what did you do wrong, or if you ever even go back to figure out what was wrong. In this way, they immediately know what was wrong, and they try to correct it. So the PSAT helps them. The video of the lectures helps them, the lecture notes. In particular, the interactive practice problem, everybody remarks that that's the thing that helps them more to learn. And the Quizlets help because they help them stay on pace. And the MATLAB, the embedded MATLAB, when we started off, we were not really optimizing how well embedded it was from the very beginning. So in the beginning, students were a little resistant to the MATLAB, not a lot, but it was more work. They didn't like it. And we kept refining it. And this is the spring 15, and they start liking the MATLAB component as well. So we kind of look at the feedback of the students, and we are more or less a steady state, making sure that everything we give them is useful. We don't give them anything that they feel like it's extra, because the time is tight, and that's the time they have. So this is a lot of blah blah on the board from open. It's mainly for me to remember what I have to tell you because it's so much stuff. So the feedback for the Quizlet is good. Even if it's more scary, you have a test every week, they help them stay on board. These are comments from the first time I taught the class in the residential way. And these are just some of them. But mainly the main problem is that they felt that they did not have enough exercises and time to solidify what they learned in practice. And they felt that a lot of time, my lectures were rushed at the end. As I was saying, I was trying to fight the clock to get the stuff in. And in general, not enough time to solve problems or understand. And then I did an experiment in fall of 2013 in which I totally flipped a part of the content, a third of the class totally flipped. I did not do any lecture. I just assigned videos online, and I did exercises in class. And the feedback was mixed. There were a lot of students that felt that the videos were not good substitute for in-person lecturing. And these are, fall sophomore and some freshmen in the spring. So they do not have a lot of yet MIT mechanism in place. So they may not have the discipline to actually look at all the online lectures. So I felt that for this class, because it's an introductory course, all the things that I think is really important, I do it in lecture. And I use only the online videos for prerequisites and for extensions. So I don't do anymore an entirely flipped content. I only flip the parts that I think are not critical for their understanding. And at this point, we are more or less a steady state. The feedback from the blended learning is generally very positive. They very much like the even simple in-class demos with like a piece of rubber beam or a balloon or a slingshot, whatever it is. It brings them back. It brings home the message. It helps them a lot, and they find that the MIT X material is very helpful. The online videos are helpful, and mainly they like the interactive solving and the expert solutions online. The thing that I'm more interested as an educator is how well these impact their understanding of the content. So this is not a science because this data is always muddled somehow, but this kind of distribution of scores for a course is the typical distribution of score that I've seen for 20 years at MIT in classes. You have very few students, 10% of the students that really get everything in the course. They get a score higher than 90, cumulative on quizzes, tests, everything else. Then you have, if everything goes good, maybe half of the course over 80. And then there is the rest of the class. And this is, when I saw this thing in the traditional course, that's it. I mean, that's the normal thing. I was relieved because the course was very fast. So it was good for me, actually, to see this. And this is the first time I taught with the blended learning online. And it was in the fall of 2013. And at the end, when I did the grades, I had 50% of the students that had over 90 total score. And 87% of the class had over 80. So they did 80 out of 100 correct over the entire over the entire course. And these are data that when I saw it, I thought, there is some geniuses class, like a total, like who are these guys? Like I gave the final exam and I thought it was horrendous and I went to grade it. I'm like, done, good, good, good. Like it took me half of the time to grade it. I'm like, what's going on? Who are these guys? Some kind of Chernobyl effect or something. I really thought that. And then what happened is that this thing continues semester after semester after semester. So this is my grades for this fall, just finished 3 weeks ago. 69 students. I had 56% over 90, 85% over 80. And this is the same person I'm teaching the same course. The only difference is they have a lot of support through the online components and the way we integrate everything in the course. A lot of people ask me, okay, this is great, but how much effort do you have to put in as a faculty to develop all this? And yes, there is an initial cost, because there is the cost to think about what you're teaching, reorganize it, and bring online all the part that can be done online. And it takes effort. ODL supports this effort greatly. There are people in the digital learning lab that support faculty. And one of our tasks is to be connections to the faculty. This is how I feel about MIT. Connection to the faculty and help faculty develop content to bring their own courses on the platform and to edX. And the involvement of the faculty on the nitty-gritty of the technicality of the technology does not need to be very deep. There is a whole team that helps with that. The faculty puts in the intellectual property, puts in their experience and knowledge, and the content is created as a community effort. I couldn't have done anything without Martin sitting back there, that was my TA for forever and ever, to help to do this material, and actually is in the trenches to do all the work to make all these things happen. All the people at ODL, at edX in the beginning, they helped us work and develop this course. The benefits for the faculty is enormous. Once you have all this content on course, you can really focus on teaching best practice that you can. It's very time effective once the material is created, and you can constantly refine and improve content with very little effort. And if somebody else comes to join your teaching team, it's easy to bring them on board on everything, terminology, conventions, everything is online. So they're easy for them to join the team and develop new content, personalize the content that's online. And essentially, you create a textbook that, instead of being frozen in time, is always evolving, is collaborative, and is always, you always try to address the best way to teach to your students the specific task that you have in mind. So that's my experience. In general, it was very positive. Thanks a lot.